Okay.
Okay, this is Live from the Table, the official podcast of New York's world-famous Comedy Cellar, coming at you on Sirius XM Raw Dog 99 and the Ridecast Podcast Network. This is Dan Naturman. I'm here with Noam Dworman, the owner of the world-famous Comedy Cellar, Periel Aschenbrand, our producer and sometime on-air personality, Nick Griffin, Comedy Cellar comedian, Comedy Cellar regular. Hello, Nick, coming to us from somewhere in New York City, I think.
Yes, Midtown, Tudor City.
Oh, Tudor City. You're not far from me. Nick, good to see you. I haven't seen you since lockdown started. I've texted you briefly, but that is also good to see you.
Good to see you.
And with us also is David Kipping. Who is David Kipping, you might ask? Well, if you're into astronomy, you don't have to ask. But if you're not, he's a professor of astrophysics at Columbia, New York, where he leads the Cool Worlds Lab, a team of astronomers studying new worlds amongst the stars. And his team researches just about anything spacey, from interstellar travel to the quest for alien life, which is something in particular that's of interest to me and what is the reason that I asked for him to be invited. By the way, is that where Neil deGrasse Tyson is from, Columbia?
That's right. He's at the Museum of Natural History, which is just down the road from us. So we see Neil quite a bit. And he's obviously a fantastic speaker, and it's always great when we get a chance to talk to him.
You're going to have to kiss his ass here. You know, we never had him on the show. We wouldn't be against it necessarily. But the reason that I reached or had Periel reach out to you is I saw a video. I don't know how, you're on YouTube and you bounce from it. Who knows what the preceding video? It could have been anything. It could have been a Madonna video. But for some reason, it led me to your video about something that's of interest to, well, probably to everybody, is Are We Alone?
The algorithm's working. How did it go from Madonna to Are We Alone? I don't know.
I don't know. I'm just saying, you never know how to put things together.
He said, are we living in a material world to somehow extra world?
Well done.
That makes sense.
Noam is not a comic, but yet he sometimes comes up with some by the way, Nick, I hope this topic is of interest to you. I don't know if Periel explained to you what we'd be discussing.
Yeah, she sent me out a bio. Yes, of course. I'm interested in the whole world.
Okay. Well,
and beyond.
A lot of people say that because and Neil deGrasse Tyson says this, and this is where I think you disagree with him, is because there's so many, how many planets are there in the universe?
A ridiculous amount. You're talking about trillions upon trillions of trillions. So, if I give it, it'd be like 10 to the 22, which means 1 with 22 zeros after it. It's that kind of number. Obviously, we haven't counted them all up, so that's just a rough guess, but it's a stupid number compared to ordinary numbers we're used to.
There's not even a word in English that, we don't even have a word for that number. It's just...
We do. It's a sextillion. It's 70. It's about 70 sextillion. I said that in my video. Yeah, loads of people didn't understand my accent. They thought I said 76 trillion or 76 billion or something. So loads of people in the comments are like, there's no such word as a dillion, or there's no such. I'm like, no, I said sextillion.
I thought you said 70 trillion. You said 7 sextillion.
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 Yes.
That's
so it goes million, like 1 billion, 2 by 2 trillion, 3 quadrillion. Quintillion, sextillion. It just keeps septillion. You keep going, so it's sextillion.
Which I guess is probably.
Who makes that up?
Is that more or less than the grains of sand in the universe?
On the beaches, you mean?
On the beaches.
In the universe, probably not. In the universe, and on the beaches on Earth, it's probably more. That's actually again like a hard thing to estimate. But if you make a reasonable estimation, it's probably more.
More or less than the amount of people that have tried improv. But seriously.
Same order of magnitude, yeah.
So with all those planets...
That was a good one, Dan.
With all those planets, a lot of people say, well, there has to be life in outer space. There's 7 sextillion. Most people don't know that word. But people say there's, with all these planets, billions of galaxies, each with billions of stars, each with planets orbiting around them. Then it's ridiculous to think there's no life. But you don't say that. You say there's a good chance, a reasonable chance, that we are alone here.
Right. I guess I would say, in that video that we shot, the answer was basically, I don't know. So I wouldn't say there's a good chance we're alone or a good chance we're not alone. I just was like very frank about it and was like, I don't know whether we're alone or not. I'd give it 50-50 odds.
50-50, but a lot of people don't say, like Neil deGrasse says, no, we're not alone. There's very little chance.
So the argument here is, okay, so if you're going to add up, let's count up how many living planets there are. It would be the number of planets multiplied by the fraction of those planets that have life on them. Right? Simple. That's the simplest math I can explain it as. So it's just multiplying those two things together, like a percentage multiplied by the number of opportunities. But if that percentage, the fraction of time that life gets going, is just also a ridiculously small number, it's 1 in septillion, just to go to like the next level. We just keep adding more and more zeros. It's like a really, really, really tiny number. Then there wouldn't be anyone else. It would just be us. And
if what is the tiny number? The chance that life forms is a tiny number?
Yeah, the chance of a planet, I mean, it's kind of an amazing process, right? You start from water, you have some organic molecules maybe, and somehow that turns into life. And we have no idea how that happened. No idea how that happened. And it might be, it's like a really likely process and there's life everywhere. Or it might be that is just like, we are just unbelievably fluky. So it's just
what you're saying is this, I think, that if you were to somehow wake up and find like that you, without, you didn't enter, but you won the one out of a lottery. You won a lottery. It was a 1 out of sextillion chance, and you're the person who won it. You would look at your tape and say, I can't be the only one who won this lottery. Like, you can't, I mean, what are the chances it could be only me out of a sextillion? But actually, if it's a 1 out of sextillion chance, there is going to be one person who's going to win it.
Yeah.
And from their point of view, it's just impossible. But it's not only impossible, it's certain, if that's the odds, that one person will win it, right?
Yeah, and it's almost like that lottery ticket. Let's say it's for a trillionaire, and you're the only trillionaire on the planet. Like Jeff Bezos might become the first trillionaire pretty soon. Yeah. And then if he was the only person he knew about, he'd never hung out with anyone else. He just would assume, oh, trillionaires must be everywhere. But no, dude, it's just you. Like, you're the only guy, and it's just you only know about yourself because you don't talk to anyone else. And we don't talk to anyone else really. We don't know anything else about other planets really. So I don't know what the answer is. I hope there's life out there. But,
comedians are the opposite. Comedians always think everybody's stealing their material.
Well, maybe the aliens might come and do that. I don't know.
The explanation that you offer seems simple enough, and even us non-astronomers can understand what you're saying. Why is it so many people like Neil deGrasse Tyson believe that the universe is, and I think Carl Sagan also, right? He also believed that the universe is teeming, literally teeming. Can anybody do a Sagan impression? No. All right, never mind.
Billions. I could. He always has the billions and billions, which I love. But he.
Why did him and deGrasse Tyson believe that the universe is teeming with life?
It's a good idea they have, and they point at what you call the chronology, the timing of when life appeared on the Earth. So if you run the tape back, you look at Earth's history. Earth is 4.5 billion years old. And for the vast majority of Earth's history, there's been life on it. In fact, life got started pretty quick. It got started within about 300 million years once the Earth was formed. So just off that fact alone, Neil and other physicists and scientists and statisticians even have said, that means therefore, like, the fact it happened so quick means therefore surely it must be easy. And that's not just in isolation, that seems perfectly reasonable. The problem with that argument is that it takes a very long time to go from whatever it was that life began as, some simple, single-celled organism, just like muck and slime, basically, all the way to something like us. And that us is important because we're the ones who are doing this conversation. We're looking back and asking how unusual are we? And so if it always takes 4 billion years to get from there to us, always takes 4 billion years to go from the beginning to us, and the clock basically runs out pretty soon. And if you realize this, but in less than 1 billion years, the Earth will be uninhabitable. So life, if that's how long it takes, 4 billion years, it kind of has to get going quickly, else we wouldn't be here to talk about it. If it happened 1 billion years later, and it takes 4 billion years to get to us, then we wouldn't be here. So the fact that it happened quick may not actually be interesting at all. It may be just a requirement for us to even exist. Otherwise, we as intelligent beings wouldn't have had time to evolve. So this is called a selection effect, or like a winner's bias, that you're looking at the, you know, what happened to you and assuming it's typical and this is the typical process. But as a winner, you are intrinsically not necessarily a typical sample. You don't have all the losers. You don't know how often life gets going and just doesn't turn into anything else, or how often it just doesn't get going at all. And so we really need all of that data before you could make that assessment. So I know that's a bit of a mind trip to get your head around, but there's just a big bias.
Are you saying that then, okay, so you're saying that that's an argument against other intelligent life that's capable of making that, of talking about it, but are you saying that there's a good likelihood of simple life elsewhere? Because if it happened quickly, does that make us think that there's probably
I guess
life somewhere else?
That's I guess, to be more specific, that's an argument against over-interpreting the quick start to life. So when Neil says, and when Sagan says, life starts quick, therefore it's easy, that's an argument against that. This is saying, no, look, if it takes 4 billion years to get to us, it has to start quick. It's not, you're over-interpreting that point. It's not actually useful information at all. It's a necessity for us to even be here to talk about it. So this is, I mean, people talk about this with the multiverse sometimes. You know, you look at the constants of nature, the speed of light, the mass of a proton, the mass of an electron, all this kind of stuff. And they all seem like the numbers are just finely tuned. So that it seems like if you just change the mass of an electron very slightly, you couldn't have us, you couldn't have a universe, you couldn't have anything. But then, you know, a lot of cosmologists studying the universe have said, well, maybe there's a multiverse out there, and we just happen to live in the one universe where things are just right for us to be here. And most of the universes are just devoid of life. And it's really the same kind of argument. It's called the anthropic principle. So if you're a winner and it's not impossible that things are just very special where we live. It doesn't prove that they're special. There might be life everywhere, but it's just we have to keep that option on the table, is my point of view.
And so do you believe in the multiverse theory?
Do I believe in it? I think I would say I would be skeptical about it at this point, because we have zero evidence to support it. It's just an idea, just a theory. So if you believe in a theory without any evidence, that's to me that's faith. Believing in something without any evidence is faith.
I tell Periel that every day. Every day I tell Periel that.
Isn't the evidence the fact that everything is so perfect in our universe that it would make sense that there was a bunch of universes and that's why ours just happens to have everything just right?
It might be that, or it might be that there's some reason that we just don't understand yet. There's some deeper theory of, you know, physics that we're yet to discover. And once we get that theory, we'll understand it and we'll be like, oh, that's why the mass of the electron has to be this. And that's why this has to be, like, now all makes sense. It's just that we didn't realize that before. So we might not need to invoke such a complicated theory. It might just be a lack of our understanding right now.
Can I ask you a question? Do you guys really, where's Periel?
Well, she went somewhere. I don't know.
Do you guys really understand?
You people? Who are you guys?
You scientists,
you guys.
astronomers. Do you people really understand, like you can actually comprehend the theories that you believe are true, like the Big Bang, like everything in the universe existed on the head of a pin, and then in a trillionth or a millionth of a second, the universe formed. Like, can you actually comprehend that, or you just like I just know that it's true, but like and time
relativity.
And by the way, let me just sprinkle in and while it was on the head of a pin, there actually was no time. Time didn't exist. Like how does a mind? Are you super geniuses? How do you understand that?
It takes a while to get used to. When you first encounter these ideas, it's very strange. But when you learn about all the evidence and you're studying it for your whole career, I guess this might be things that happen. I don't know if an example in comedy, because I'm not a comedian, but maybe there's like some subliminal things that happen. You can read the room in a way, and you just get used to it, and you start to develop a skill at it. And I think astronomers have a skill now at conceptualizing some of these grand ideas in a similar kind of way. You know, there's air in the room. We can't see it, but we know there's air in the room. We've been told there's air in the room since we grew up, and it makes sense to us. And there's evidence. You can show evidence for it, but you can't see it. And it's kind of hard to imagine all of the particles which are like smashing into your face every second. Right? It's just trillions of particles smashing into your face. But you can kind of prove it because you can feel like a compression if you take the air away out of the room.
No,
it'll do terrible things to your skin.
I'm accepting that there's air, but I'm kidding. And then, well, I mean, I just understand, like, you have something and it exists, but it exists in an instant without time. And then the other question, obviously, is like, well, where did it come from? All the material of the universe on the head of a pin. How do you comprehend the idea that something always existed or came from nowhere? I bang my head against the wall trying to understand these things. Can you help?
Well, those are good questions. And we don't, some of those questions you point out there, we just don't know the answer to, and that they're very good questions. So when you say, you know, where did it all come from? What was before the Big Bang? Like, nobody knows. That's something we're trying to figure out. As far as we can tell, the reason why we think the Big Bang is right is because when you look at all the stars, all the galaxies, especially distant galaxies, they're moving away from us. Everything's moving away from us. And the further away something is, the faster it's moving away from us. So that's consistent with basically taking like a rubber band and stretching it out. And at one point of the rubber band, you look at all the other points in the rubber band, everything looks to be moving away from each other. So that implies if everything's being stretched, if you reverse the clock, it must contract to a point. And that's really it. That's pretty much the extent of our understanding. That as far as we can tell, the universe as it is now, we don't have like a time. I can't fly back 13 billion years really and see the universe back then. As far as we can tell, the universe must have begun from a point. Maybe it began as a ball, but maybe it truly wasn't a singularity. It could have been a smaller volume that was kind of static for eternity, and then just something happened and it, for some reason, exploded. But it's almost like here be dragons. These are just things that we do not know the answers to. There's lots of interesting ideas, and it's fascinating. And this is why I love astronomy, is that we don't know all the answers yet. It's kind of boring if you work in a field where everything's been figured out, I think.
It's unbelievable.
Nick, are you being silent because you are a Neil deGrasse Tyson, acolyte?
I'm just furious because I know that he's wrong, and no, not at all. I guess what I was curious about is have you gone back and forth on this view that there's probably not life, or is this something you kind of settled in early on?
He says that it's probably 50-50 given what we know, that life, that there's more life.
I just say I don't know. That's it. It's people try to let a sign that I have a belief on this, and I'm like strongly fighting either. I'm not. I don't know.
And you have a belief compared to those that say, like Sagan and Tyson, Neil deGrasse, not Mike, although Mike may or may not have an opinion on the matter, that they say, of course, you have to be an idiot to think there's no life out there. You're not in that camp, so you do have an opinion,
I mean, it's not just me that thinks this as well. I mean, like Sean Carroll, for instance, is another famous person who stepped out and said this as well. So the problem is you just don't know, as I said, you don't know the probability of life and even intelligence.
So why does Neil deGrasse think, are you saying that Neil deGrasse, and I hate to use the term.
You called him stupid, I heard it.
Are you saying he's a buffoon?
Hey, very smart people can disagree. That's okay. We can have different
I have a question. What kind of evidence would you need in order to say that, yes, there is life on other planets? Like, the people who believe that there is seem, really sort of almost obsessively convinced of this. But what would someone like yourself or an astronomer who takes your position need to come to that position?
We need reproducible evidence. I mean, all of science is based on reproducible evidence. It has to be an experiment or a test that you can do. Different labs can do it, and we can all agree on the same answer. That's sort of the underpinnings of science, is something reproducible. So that could be, in the case of looking for life, let's say we sent a rover to Mars and it detected a biosignature. So actually, there are some hints of biosignatures on Mars. It's very interesting. But
You'll forgive me. What's a biosignature?
Oh, sorry.
Oh,
A
Periel.
biosignature is a
Tone us down, Periel.
Come on. A biosignature is a gas that life produces. So when cows fart, that's a biosignature. That's methane. That's literally one of the things we look for is cow farts, basically. And oxygen is another biosignature because plants produce that, and oxygen oxidizes stuff. So one of the, it shouldn't hang around. If like you killed all life on the Earth, it just disappeared tomorrow, the oxygen would probably go away after about 1 million years. It's about how long it would last. And so, in the grand scheme of billions,
it's like an
of
Armenian
years
fart.
History. So these farts, these gases, we're looking for them on other planets, and if we see them on either Mars, Venus, or another planet, even around another star, that's a pretty good sign that there's someone living there, something living there. So far, we've not really had the technology to do that, but we're starting to get there. So I'm kind of optimistic we'll be able to do that experiment in our lives and get an answer.
And is there a planet that would be most likely to occur on with the information that you have now, or?
So some of the best places in the solar system to look for life would be Mars and Europa, and maybe Enceladus. So Europa is a moon of Jupiter, and it's covered in ice. So it's just, you look at the surface, it looks like a snowball. And beneath that icy crust, there's actually an ocean beneath it. And no one's ever probed inside that ocean, but we know there's liquid water beneath it. And so it's very enticing, right? Because if there's liquid water, there's a possibility for a whole biosphere, an aqueous biosphere under there. So it's super exciting, the idea of sending a probe there, drilling down, getting a little submarine to swim around and maybe bring back some Europa sushi or something for the trillionaires to eat. But this is an experiment we could do, but it would cost a lot, but we could do that experiment.
And related to this then, how ridiculous is the idea of God?
Well, that's kind of outside the realm of physics and science, I would say. I'm going to kind of skip a bullet on that one. I have my own personal beliefs on that, but there's no experiment I can do that would provide any evidence either way. So I can't really, it's like saying, can you provide me evidence of the multiverse in the same way? There's no experiment I can do.
What about evidence of the multiplex, the one on one in Periel off Route 1?
I haven't seen much evidence of that lately.
What you just said was kind of what I was getting at, is that there are a lot of theories out there that scientists seem to believe, or I don't want to say they believe them, but they think are plausible. Yeah. That seem to me to be no more or less plausible than the idea of God. I don't believe in God. I don't believe in them. I'm with you. I don't believe in anything I can't that can't be proven to me.
Yeah.
God is like this. When these people start believing this stuff, then why there's such a snob about God? Why is that any less plausible? Why, if the universe could always be there, why can't God always been there? If all the matter on it can exist on the head of a pin and form a universe in a fraction of a second, well, why couldn't God, do that in a fraction of a second?
Right.
Yeah. Well, if you read what's his name, Dawkins, he addresses pretty much all the questions of that nature. Noam, you've read Dawkins?
Yeah, of course.
He's another one with an English accent, right?
Yes.
Yeah,
I find the whole thing disconcerting. You put an English accent, you have to you can't even question it.
People question me all the time. I don't worry about that. Look, the thing is with the science and the faith stuff, it's you were right. There's an interesting metaphysics overlap almost. Another one is like the simulation hypothesis that kind of gets into this. Like, do we live inside a computer? Elon Musk is a big fan of that.
Yeah.
And string theory is another, there's no experiment you can do, but it has these advocates.
String theory? Tell Periel what string theory is.
Okay, so string theory is...
I love how you rolled your eyes when I asked that last question. Did you know that there was an ocean under the crust of Europa where you could...
Yes, I know that. Every Snapple cap has that. So go ahead.
String theory in a nutshell says that all of the, you look at the universe, we have all of these different particles, electrons, quarks, leptons, all this kind of stuff. And the basic idea is all of that stuff is the same thing. There's just one thing, and it's a string. And it's like playing notes on a violin or a guitar. Different notes create the different elements, the different subatomic particles. So an electron and a muon are the same thing. It's just that they're playing at a different frequency, and it's this a string vibrating at a different frequency. So truly, reality is just a crap load of these tiny strings everywhere.
Is that related to this idea of these particles that you do something to the particle here, like on the other side of the world, the particle reacts to it or something? You know what I'm referring to? Yeah,
that's quantum entanglement. It's
not the same thing?
That's a subatomic effect, but it's not directly related to that. The concept that everything can be explained as strings. But string theory is attractive to a lot of people because maybe I didn't describe it very well, but it is very elegant. It's kind of beautiful in a way that you can just describe everything with this analogy of like music. It's kind of very attractive to a lot of people.
Go ahead. I'm sorry to interrupt you. Go ahead.
It's right. It's mathematically very beautiful. And so a lot of its proponents point at that and they say, look, it's so beautiful. It's so elegant. Therefore, how can it be wrong? Because they're guided by the maths more than they are by the experimental verification, because there is zero experimental verification. So that's kind of it, really. And that's why it gets into faith.
How does subatomic entanglement work?
The same reason people like Governor Cuomo, because it's elegant and looks good.
Yeah.
Quantum entanglement, it's a bit like a good analogy for this is like if you buy a pair of shoes and there's a left shoe and a right shoe in the shoe box, right? And you always get opposites. There's always a left shoe and a right shoe. And the same way, if you entangle two particles, they have kind of opposite states. So one could be spinning one way and the other one's spinning the other way. And if you separate those two particles and you separate those two shoes to the side of the universe, and you don't look at whether the shoe is left or right footed, and then someone on one side of the universe opens the box and they see it's a left footed shoe, you know immediately the other shoe has to be right footed, even though you didn't receive a signal or anything from that shoe. But you can just by almost deduction tell it's a right footed shoe. And quantum entanglement is just like that, except that with shoes, of course, it really is in the box. It really is either a left-footed shoe or right-footed shoe. It truly has one of those states. But for a particle, they get really fuzzy, and they really don't decide in a very literal sense what they are. They don't decide whether they're left or right until you open them. And so by the act of like opening the box, you force it to choose, and then you force that other particle to go the other direction. So that's quantum entanglement.
So how does another particle on the other side of the universe know what you've done to a particle on this side of the universe? How does that work?
How does it know? I guess.
I know David Copperfield would love to have that secret. I mean, that's like, how does that work?
There's no communication between them. So you can't truly use this. I mean, in a way, they are kind of forcing each other to make a choice, and they're always opposite choices. But it's been shown in many experiments and theory papers that it's impossible to like use this as a system of, instant communication or instant teleportation, I think. The exact mechanism by which this happens, I don't think we really understand it. I certainly don't understand it. I work in astronomy and I'm not a quantum physicist, so I'm not afraid to say that I don't understand the mechanism by which that happens, but that is effectively the observation and the behavior of this state.
No, I want to get another area of David's expertise is, or at least another video I saw was about how the world ends, which is appropriate now because we're living in crazy times and some people think the apocalypse is upon us. But David Kipping, how does Earth finish?
Well, in about 1 billion years, maybe even a bit less than that, 900 million years, it will probably be impossible for complex life like us, by which I mean really multicellular life, to persist. So what's happening over this period of time from now until then, and has been happening actually since the sun was born 4.5 billion years ago, is the sun is getting more luminous. It's producing more energy over time. It's actually producing 30% more energy now than it was when it was born. So we can tell this by looking at other stars. You can look at stars very similar to the sun, born with the same masses. Stars are actually remarkably simple. They're pretty much just controlled by how heavy they are. Once you know how heavy they are, they all kind of look the same. So we can look at stars at different ages and see, almost like looking at the sun back in time in its different states. So the sun is getting more luminous over time. And as it gets hotter and hotter, if you like, it's going to make the Earth hotter and hotter. And the atmosphere and the Earth reacts. So the Earth has actually remained fairly stable in temperature for this entire time. So why has that happened? When the Earth was first born, it had lots of carbon dioxide. Right now, carbon dioxide is the enemy, right? We're trying to get rid of carbon dioxide because we're making the Earth too hot by having too much of it. The Earth probably had like a ton of carbon dioxide early on in its life. And that was actually a good thing, because if we hadn't have had it, we would have frozen over because the sun was so cold. So the carbon dioxide in the past was actually a good thing. And as the sun got hotter and hotter, warmer and warmer, it caused the planet to get hotter and hotter. And that causes more precipitation, more rain to come down through the atmosphere. And what happens is when it rains more and more, the rain absorbs carbon dioxide, the rain droplets absorb CO2, and it forms what's called carbonic acid. So it's like a very weak acid. And that acid then dissolves rocks when it hits the rock, like very slightly. It's a very slow process, but it will dissolve rocks. This is a type of weathering. And then eventually, all of that carbon just goes down underneath the Earth, essentially. So you're removing CO2 from the atmosphere and putting it into rocks and substrates in the bottom of the ocean floor. And that's been happening forever. So if you look at the Earth's history, the temperature of the sun is basically getting, well, it's actually really the luminosity, but the luminosity of the sun is getting warmer and warmer, and the CO2 is going the other direction, down and down and down. And that's going to continue. And there's a threshold. And the threshold is that once CO2 gets really, really low, right now it's about 400 parts per million. Once it gets below about 10 parts per million, plants can't survive. Plants need CO2 to survive. They use it for photosynthesis, to make oxygen, to survive. And so once CO2 gets below that level, which is inevitable by this weathering process,
and how long?
It's game over.
Well, how long till the game over?
That's 900 million years. So we're in actually the last 20%, maybe, no, actually the last 15% of Earth's habitable window. We appear, we're like in the end game, like the last quarter, even the last half of the last quarter is when humanity appeared. We're right at the end of the story. And so this is why I think we might actually be rare. It's kind of, if we're really common, it's kind of suspicious that we emerged so late. And so you don't want to overinterpret that, but there are some things about the timing which kind of, are interesting here. But that's just when life ends. The Earth will still be around. There'll still be an Earth. Probably very simple microbial life will survive after that point. Eventually, even the sun will get so hot and so big, it grows bigger and bigger, it will actually engulf the Earth, and the Earth will fall inside the sun altogether. So that will not be a nice day, but that's about 5 billion years away. So,
and would you trade the rest of your life just to be able to see that?
Yeah, it'd be pretty fun to stand on the surface of the Earth watching have you ever seen Sunshine?
No, I know what you're talking about, though. Sci-fi movie, English sci-fi movie.
Is it Danny Boyle? I think.
Danny Boyle, yeah.
Yeah, and there's a scene right at the end where they're like flying into the sun, and the sun like almost touches his face, and it'd be pretty epic for a sci-fi film. Yeah, we did a video about it because I thought it was such a cool visualization and cool idea.
So if I do something immoral, there's really the universe.
When you do something immoral,
the universe doesn't really care, does it? I mean, I imagine as a scientist, you must say, "Well, I think I can. Whatever. No one's gonna know the difference." Like, objective morality is for the for the little people. They believe anything.
Yeah, it's interesting. I mean, I kind of think it the other way. I'd say that especially the way we treat each other, it kind of gives me more respect for that, because the thing is that we could be like very unusual. Even in our solar system, clearly the majority of the solar system doesn't have intelligent life in it. And even the most nearby stars, I mean, this is another thing we could talk about. We've been listening for radio signals for a long time. We haven't heard anything. As far as we can tell, it doesn't seem to be anyone out there. And so if we really are very special, you could travel for thousands, millions of light years across the universe and never meet anyone who you could have a conversation with. And so every single person you meet in the street, even if you violently disagree with them, you have to kind of appreciate the fact you could travel in either direction, and there's no other human being or person that will understand you like that person stood in front of you, just to the same degree. So it's not quite the same thing as morality, but it's a respect for life, I think, is something astronomy gives you.
I nominate Periel as Earth's ambassador to have conversations with the other planets.
I would be able to handle that very well. So if this is like all sort of determined already, like it's done in however many million or billion years, what's with global warming?
So this is a much shorter term issue. So we're talking, with the end of the world, we're talking in terms of what we just described, that's a billion years.
Yeah.
Right. So humanity arrived on the scene 200,000 years ago, basically. That's like nothing. That's like literally the fraction of a second compared to this time scale. And so global warming is really concerned about very, very, very short term changes compared to this time scale. As and it's going to happen at the end. We're reducing CO2. That's essentially what it's called the long carbon cycle, and it's reducing CO2 over a long time, but it's nowhere near fast enough to outpace what we're doing to the atmosphere right now. And so the danger is, if you take all of the CO2 that the Earth has been sequestering since the very beginning of Earth's history, and you just somehow get it all back up into the atmosphere, you could just switch it over and put the Earth way too hot for us to survive. So these processes are natural, long-term, stabilizing equilibrium processes. What we're doing is not an equilibrium. So that's the danger, is that we could, maybe life would survive past it, but agriculture, our cities, our coastal cities especially, are going to be so severely affected by this that it would be a very bad thing for the economy and for our way of life. But it's not quite the same.
Is there no chance for a technological solution to global warming, some way to take the resequester the carbon?
Yeah, absolutely. Using these same kind of principles we were talking about, like weathering, there's one thing you can do is called enhanced weathering, where you basically take the physics of what's happening with that weathering process and just gear it up and make it happen faster than it naturally does. And thus you're accelerating that pull down of carbon dioxide out of the atmosphere. So that's like the negative carbon sort of future that we're trying to move towards. So technologies are emerging. I was actually in Iceland last year, and I was looking at a plant there where they do this, and they're not actually pulling it out of the atmosphere. They're producing CO2 inside their power turbines, but then it all gets trapped, and they tunnel it back down, and it mixes with water, and they push it down into the rock, and then it solidifies as new rock. So the CO2 basically forms new rock. So that the CO2 never gets out into the atmosphere.
I don't want to get bogged down into a global warming discussion, Noam. We brought David here to talk about the universe. I
didn't bring it up. That was Periel's question.
No, you said, is there a technological solution to global warming?
Yeah, well, if we're talking about the end of the world, that's what I know, yeah.
Well,
I worry about it. I worry about it a lot. It's fine.
The better question would be, is there a technological solution to the sun's increasing luminosity? And
we'd have to move somewhere.
We'd have to go somewhere else.
Yeah, it's this. I was actually thinking about this the other day. I have a wacky idea. I haven't told anyone else this. I have a wacky idea of how to solve this. If we made the sun, if we took away the sun's mass, we made the sun way less, that would probably do it, is my guess. And the reason is because if you look at most stars in the universe are actually lower mass stars than the sun. The sun is actually freakishly heavy by most standards. The sun is not a typical star. Only about 10% of stars are similar to the sun. 3/4 of all stars in the universe are about half the size of the sun, and they're called red dwarfs. Those are very, very common. Those things, because they're so small, they're so pathetic, really. They're barely big enough to have fusion inside them. They last forever. Those stars will last for trillions of years, way, way longer than the sun, because they're just
convert the sun into a dwarf.
Yeah, so what we could do is pretty much de-age the sun. We could do like people de-age themselves on the surgery beds. We could de-age the sun by just taking mass off it. So if you parked a heavy object nearby, it could actually pull matter off the sun. We see that actually all the time. There's these things called binary star systems. And sometimes you get like one very compact object next to a star and it sucks all the mass off it. And that happened, we see that happening.
What's that?
Godzilla.
What about the odds of a dinosaur-ending asteroid? Was it an asteroid or a meteor or whatever it is? I don't know the difference. Can that happen to the human race?
Of course
Sure.
it can. Of course it can, and will, in all likelihood, if we make it that far.
I think we're almost overdue for one since the last major one. Yeah. So there is a big effort NASA is very concerned about this. There's a serious effort to try and locate all of the nearby asteroids to the Earth. So far, we've mapped all the really, really big ones that give you like extinction level events. We've pretty much got most of those, like 95%. The ones that could destroy cities, that kind of size, they're smaller, they're harder to spot. Those we don't have a very good handle on. So we only know of about half of those. So it'd be great to send more missions up to try and catch those, because one of them could smash into New York and there's no more New York.
Can I say one other thing to follow up? No, shut up. Just because you said we're overdue.
Look Periel's face.
I know you said overdue.
Yeah.
And I think you mean that. I think you mean that colloquially, but I do remember learning this in high school. That's one of the. So we're not actually overdue, right? Because the odds, like if you get 100 heads in a row, you would say I'm overdue for tails. But actually, on the next flip, the odds are no better than they were for the previous hundreds of
right. It's just a law of averages. So roughly every 100,000 years you get sort of an extinction. So every 100 million years you get an extinction level event. So that's almost about 65 million years ago. So we're sort of in the range where odds are you'd expect it, but it doesn't mean it's going to happen tomorrow. It could happen in 2 million years, and that would still be completely consistent.
If something the size of the moon, a meteor the size, are there any meteors that big?
No, I mean, that's almost a planet-sized thing. I mean, the moon is bigger than Pluto, for instance. So that's a pretty big object.
I'm saying something like, what's the biggest meteor out there that we know about?
Well, like it depends on exactly how you define it, but like Vesta is like a very, very large object in the asteroid belt, for instance. But it would take a lot for that to hit us.
Vesta smacked into Australia at full speed, whatever the full speed. How long would I live here in New York City?
I mean, if it hit Australia, then it's just basically a shock wave that's going to propagate around the Earth, and that'd be just incineration. If it was something the size of Vesta, that would deform the shape of the Earth. It wouldn't even be a spheroid anymore after it's hit us.
But can I survive?
That'd be obliteration.
Event.
No bunker would help you if that happened.
Dan, have you not looked at my background here? Does that mean nothing to you? Why would you even ask a question like that? It's all right there.
How long would I live in New York after after Vesta hit Australia?
Like, I don't know, maybe an hour for it to propagate around. It'd be very soon. The more likely case is something smaller than Vesta, which wouldn't actually incinerate you, but it would just make the sky turn black for a long time.
Vesta would melt the Earth. It would just like melt. The Earth would become like
that would be very extreme. That would probably destroy the entire crust of the planet, because that's a very massive object. The moon formed that way. That's how the moon formed. It was another planet that smashed into the Earth, and the debris of the Earth from that collision made the moon. So we think that's how the moon actually formed. This has happened to the Earth in the past.
Again, the question comes up.
It was a very bad day.
The question that keeps coming up is how cool would it be to see that, even though you wouldn't live very long?
It'd be pretty awesome. The most actually amazing moment would have been just after the moon formed. I don't know if you know this, but the moon is moving away from us about 4 centimeters per year, about an inch per year. So when the moon first formed, it was about 30 times closer, and this would have been 30 times bigger in the sky. And it would have been a big ball of molten rock, so it would have been glowing red hot. So that would have been like a pretty amazing moment to have seen the first moonrise and seen this giant forming spheroid of hot magma float up and consume your sky. So that's the moment I would flick back in time to and see if I could.
I do, by the way, want to get to Nick. We're going to get to your special.
Don't bring that up.
Pardon?
Yeah, that's great.
No, we're going to get to that. But first we're talking about the end of the world.
Well, I wanted to ask him, like, he's obviously a super intelligent person, and I was wondering what early on in your life hooked you into astronomy and what you're into now. I mean, you could have obviously gone in many different directions.
Yeah. I think I've always loved space. I've always been a big Star Trek nerd. Loved Star Trek growing up. TNG was Star Trek Next Generation was like my thing. So I loved sci-fi, space. I thought I'd be a physicist. I really loved figuring out how things worked. And when I was a kid, I used to draw the plumbing system of the house. My parents thought I'd be a plumber for a long time because I was really interested in drawing the plumbing system. So I just always liked how things worked. And physics seemed like it was how everything works. So I was just sort of I studied that at college. I was good at maths. So, some people get turned off from it because they find it really hard. I find it easier than writing essays personally. And then towards the end of my degree, I started to get this feeling that everything in physics that was important had been figured out, that we kind of knew of all the particles. Mm-hmm. We sort of knew the basic laws of physics at this point. And surely there are things still to discover, of course, but it's getting harder and harder and harder to make progress. You have to build ever larger particle accelerators.
The next frontier is in physics, I think, is consciousness.
That's almost interdisciplinary. That's starting even going beyond physics. You're merging physics with other fields at that point, and that's super cool. But for me, I was interested in the low-hanging fruit, and for me, the low-hanging fruit was there's 100 billion stars in our galaxy, and we've only studied like a few thousand of them. So there's only 10,000 astronomers on the planet, professional astronomers, pretty much. Wow. So for every one of us, each of us has like 100 million stars or something we can just have all to ourselves. It's just like, there's so many stars out there. There's just, you're never going to get bored. And so that to me was like an ultimate, it's like going into a sci-fi game, a computer game that just has unlimited things to explore.
Right.
That's how I felt doing astronomy. And that's why I was drawn to it.
Are you guys like do you kind of know each other? Like in the comedy world, I don't know. I was joking that, there's a lot of people that have tried it. There's a lot of comedians, but there may be about 10,000 comedians worldwide. I don't know. It could be about the same number. But here in the United States, we all kind of know each other. I don't know if there's an astronomers, you all kind of know.
I mean, I don't know every one of those 10,000 people, but there's certainly the big shots in comedy that you guys all know, and there's the big shots in science that everybody knows. And then, people working very closely in your field I mostly work on planets. So most people who work on looking for new planets, I probably know their name, and I might have met maybe, 20% of them at conferences or things. So yeah, it's kind of a small world, and I like that. It's not too big that you can actually remember people.
I have one more question that I just wanted to ask, and that I personally was interested in asking. This is something that gives me nightmares. What are the chances? Is there a chance about that the universe expands, right, and then it contracts again, right? And that's one of the theories, like the big crunch, where it expands, and then it contracts and goes back to where it was before the Big Bang, right? That's a theory. Now, what are the chances that it will explode again as another Big Bang? Could there be another Big Bang? And if so, will it play out exactly the same way, ruled by this? In other words, kind of like a ball bouncing up and down, or like a pendulum swinging back and forth. And I got to do this shit again and again and again for eternity.
Right. I think that's unlikely.
Is that a possibility?
There's two reasons why. The big crunch, most scientists don't think, most astronomers don't think that's the right answer anymore. That was kind of fashionable a few years ago. But when we look at, there's no sign that the universe is slowing down. It's just, if anything, it's getting faster and faster, the rate at which it's spreading out. So that's dark energy. So we don't understand what that is, but it doesn't look likely the big crunch is going to happen. But even if it did, all of the complexity in our universe, like the galaxies, the structure that we see, all of that was basically just like a quantum fluctuation that happened in the first attosecond of the universe's existence. And quantum physics tells us, if it's right, that the universe is basically just random. The thing that really is like an intrinsic randomness to the way things happen. And so if that's right, then it'd be the same laws of physics probably. We'd still have planets, we'd still have stars like the sun, but I don't think you would exist. I don't think it'd be That's like a parallel dimension.
I don't mind coming back. I just don't want the same thing over and over again, you know.
Well, you know what? If the universe is infinite, then that would happen. We don't know if the universe has an end. It might just go on and on and on and on. If it goes on and on and on and on, then there would be another you. There would be in fact, there'd be an infinite number of yous doing this show right now.
Is that a
infinite number of me's answering this question?
Oh, is that a certitude? Is that a certitude?
Yeah, with infinities, everything's a certitude. If you have infinite opportunities, it's like infinite rolls of the dice, then you will roll an infinite number of times. So, but that's a little bit, again, metaphysical and philosophical, I would say, because anything beyond...
The best chance of life after death is that, I guess. The best chance of life after death is an infinite, is time is infinite, and we just come back again. Oh. Maybe,
but yeah, mind transfer across the universe or something. Maybe, I don't know. I don't worry too much about that, but it is an interesting philosophical thing.
Well, if anybody else doesn't have questions, we can get to Nick's special. Unless if somebody has a burning question, either about the end of the world, or exomoons, which is his specialty, but I just didn't have any exomoon questions. That's a moon outside of our solar system. That's like your specialty, right? The exomoon.
Yeah, that's kind of my thing. Yeah, because no one's ever done it. It just seems like we found 4,000 planets. Let's get the moons.
I got to be honest with you. It doesn't turn me on, this whole exomoon thing.
Well, it's a moon. You know, if you've ever seen have you ever seen Avatar?
No, I never saw it. That's
usually my best sales pitch. If you've seen the film Avatar, they live on the moon. And so, you know, there's lots and lots of gas giants like Jupiter just hanging out around these stars at the right distance where they could have life on them. But of course, it's a big ball of gas, so you can't have life on them. But the moons, they could be the place where we have life. So if you're interested in looking for life, it might be that there's a lot of life on these moons, actually. So that's kind of the usual thing that connects people to this subject.
Oh, okay. Well, that's more of interest to me. Just an exomoon in and of itself, I could take it or leave it.
I make a cocktail called an exomoon. That's worth taking.
What's in that?
What's that?
What's in the cocktail?
If I told you that, Periel, I'd have to kill you. You'd have to pay me a lot more for that secret recipe. That's only served at astronomy events. It's like KFC, the secret rub. You know, you can't.
Nick Griffin has a special out on where is it, Nick? It's called
it's on Amazon. It's called Cheer Up.
It's called Cheer Up on Amazon Prime, I guess.
Yeah, you can get it on Amazon Prime. Yeah.
Now, is it Dr. Kipping or just
Doctor or Professor is fine.
That's a Kipping. I don't know if you're familiar with Nick Griffin's act. He's very it's dark.
That sounds good.
That's a hell of a sales pitch. Thank you.
The universe is dark, so we astronomers like dark comedy.
So he goes there. He goes to places, dark places. So is that what we can expect on this special, Nick?
Yes, it's pretty consistent with what you've seen over the years, Dan.
Well, what topics in particular are you addressing on this special?
Oh, for God's sakes. I don't know. Depression, divorce, taking a bath, all the biggies.
Does talking to Dr. or David or Professor Kipping, does it make you less or more depressed knowing that that the Earth is going to, just not exist in 5 billion years, and we're going to be melted by the sun? And Noam Dworman has started screen sharing. I don't know what you screen share. There's Nick Griffin.
Oh, there's me, yeah.
They can still see us. They push it off to the side, Dan. You can keep talking.
Okay. Oh, Nick's, by the way, Nick's what we call a silver fox.
Yeah, that's a good photo, man.
You've heard of a red giant? Nick is a silver fox.
I need you a photographer.
Yeah, does this stuff bum you out to hear this, Nick? We're talking about the end of the world and the...
No, it doesn't bother me at all. No. I mean, I haven't had a particularly sunny view of the world since I was about 7. So,
wow, Nick.
More information is not it's not help.
You know, they say, like, I've been reading about how little kids don't understand
I love
death.
doing stand-up, though, so that cheers me up.
I've been reading how little kids don't understand death right away. It takes them a while to process it. I remember getting it right away. In my memory, as soon as they said, yeah, this is like, I don't know how old I was, 4 or 5, and my parents said, yeah, you know, they mentioned that somebody died, a relative, and I said, well, what's death? And they said, oh, that's, you stop living, it's over. And I remember, unless I'm wrong, I remember I got it right away.
Yeah.
Right away, I knew, okay, that's, you know, just as before I knew that I hadn't been around 10 years prior, and the idea of not being around after dying, I got it right away. Maybe I'm a prodigy of death acceptance, but.
I'd also like to say that I grew up with a very nice parents. Everyone was nice to me, and it still didn't work out. So it's not anyone else's fault.
Dr. Kipping, you think what? Are you
Well, I just say no. I don't find astronomy depressing at all. Actually, I kind of think like the opposite. Like I think everything's basically this cosmic fluke, right? And like the lottery ticket analogy, it's just like it's kind of ridiculous that we even get this opportunity to be alive. Is kind of the way I think about it. Like there's no reason, there's no fate, there's no predestiny. It's just an absolute fluke that we're here, as far as we understand it. And so to me, that's just like a gift. It's like you've got these 100 years. It basically means nothing. Maybe if you're lucky, 100 years in the cosmic scheme of things. And so every moment is just kind of precious and wonderful, and like it's blessed in a way that you got it. So I don't think of it as depressing. I think of it as like, why should have I expected anything more than this? This is kind of ridiculous that I got this much.
Well, I look at it like ice cream. I mean, unless it's going to be enough for me to really just be, you know, sick of it, I'd rather not have any. Because now I'm like
all or nothing.
Well, I'm into it, and then you're going to take it away from me.
Well, it wouldn't be worth, you know, if you had too much of that ice cream, you wouldn't enjoy it too much. So I think having just a small amount is actually the best.
This is metaphysical. This is not your field, but you're a smart guy. Maybe you can follow along. We say, you know, the expression life is short, right? I mean, you've obviously all heard that expression, life is short. It certainly feels that way. Is there any amount of life where we would say that's about right? I'm full. You know,
ask different people, you'll probably get different answers.
Would it be short no matter how long it was? Because really, what's it short in comparison to?
I mean, your life could be torture from day one, in which case you don't want to, you know, a year is too long. Or your life could be every day so different and so fulfilling and so rich that you just want to keep going. So I don't know. It so depends on what you do with your life, I think, as to how much.
Say life is short. Would it exist if we lived to 500? Would people even say life is short?
Some people probably would. I think, yeah. I think.
How long would life have to be before we started reevaluating marriage? Like, you know, before it's like, it's not going to commit. It just doesn't make any sense. Like, I'm not going to commit for 1,000 years.
I think by 150, 120 to 150. I think when people start living on average to 120. I think marriage will be reevaluated at that point, when and if that happens, which it probably will.
The thing is, we're not going to talk about 120.
Pardon?
Go ahead, Professor. Professor.
Pulling rank. No, go ahead. You go ahead first.
I just want to say that I don't think it doesn't seem to me we're living much longer than we ever did. I was looking up like how long the founding fathers did, and like except for George Washington. Our founding fathers, you know, on this side of the Atlantic, they all lived into their 80s, 83, 85. I think one of them lived to be 90, meaning that, you know, we're surviving childhood better. But it doesn't really seem like with all the medical science, they've really pushed the boundaries of how long we can live all that much. I mean, maybe it's some diseases, they've raised the average because they've conquered certain causes of death that had a higher probability, but nobody's living to be 110, 120. Like they're still living to be around 90 if you're really old, 95, like they did 300 years ago or 200 years ago. It's very depressing actually that they haven't really made that much progress when you think about it. Anyway.
Yeah. I think the outliers, the oldest people have always there's like a ceiling up there, yeah. And you're pushing the curve up. Right. So there's probably a lot of people that died in their 40s without proper medical treatment throughout most of their lives, you know, hundreds of years ago, and you're kind of pushing everyone up. But there probably is some ceiling that we're hitting. Yeah.
depressing. All right.
Noam just wants to see. Noam wants to see what's. He said to me that he wants to live a long time just to see what's coming. That's the only really shot we have at time travel is living long. To see the future.
Well, I want to see my kids grow up. Oh, sorry, Professor.
Professor, I'm going to ask you, Professor. I asked a question of Noam. I asked this question to a lot of people. If I could give you a week in the future, as a guided tour of a week at some future date, 1 week, and then you have to come back. When would you pick? How far into the future would you pick, and why, for that week-long guided tour of the future?
I think I'd probably choose about 1,000 years, something like that. There's an idea called the doomsday argument, which predicts the end of humanity in about that sort of timescale. So I would be curious to see if we outlasted that prediction.
Is this the same British modeler that predicted 1 million COVID deaths? Is that what's his name?
Maybe he made that prediction, but I'm thinking of Richard Gott from Princeton. Oh, yeah. He's a physicist. I'm actually reading a great book all about his career at the moment called the Doomsday Calculation by William Poundstone. It's on Amazon.
He just came out recently. We won't be here in 1,000 years. That's the hypothesis.
His basic argument is it's what's called the mediocrity principle. You're probably not the first human beings to ever live, and you're probably not the last. You're probably somewhere in the middle. And so if you just, you add up how many humans have ever lived, it's about 100 billion. And so you would predict another 100 billion is probably how many more there will be by that principle. And if you look at the birth rates and death rates, yeah, there it is, then that gives you about 1,000 years to play with, something like this. So the argument is if you live somewhere in the middle of all people, then it's actually, given how many babies we're pushing out right now, it's actually not that long to go until the end. He used this calculation on the Berlin Wall quite famously, and it worked. And it was used even to some extent by the Allies during the World War II on German tanks to predict how many German tanks would be produced. And it kind of worked quite well in both cases. So it's a little bit of a
mathematical argument that might be beyond the scope of this podcast. But more, the book is, what was that book? A Noam show.
I don't know why I'm plugging this book, because I have I don't get any income off it.
We're about to
use a calculation.
We're about to wrap it up. If you have a book that you'd like to plug.
I don't. No, I'm not. I'm too busy looking for moons and planets to write a book, but maybe one day.
So publish or perish does not exist in your line of work, in your field. There's no publisher.
Research papers. I don't want to push my research papers on people. I don't think anyone deserves that affliction to be forced to read that. But check out our YouTube channel. We have a YouTube channel called Cool Worlds that we do explainers of all the science, which is way more
cool
accessible.
The YouTube channel. Why are you not that you want to be, but what does Neil deGrasse have that you don't have? You seem that you have that fancy accent. You're very personable, or maybe you're just not interested in pop science.
Well, I don't know. I mean, he does that full time. He doesn't really do research. I spend most of my time doing research. So
I'll tell you where you're going wrong, Professor. Nobody wants to book the guy who says there's no life in the universe. We want to hear from the guy who says there's Martians. That's just the bias, That's why Tyson is a household name, because he tells them what they want to hear.
Tells you what you want to hear.
Yeah, absolutely.
I think that's a good point.
There he is.
Absolutely.
I think that's a good point. Anyway, well, we like you.
I appreciate that, and I'm happy to spend this time chatting to you guys. It's been fun.
And also, you live in New York. When the Comedy Cellar reopens,
if and when,
well, there will be a when. We know that
Stop
it's open.
Maybe that formula can tell us when the Comedy Cellar is going to reopen.
Year 3000.
Figure out the tanks.
If you would like to come to the Comedy Cellar and get food, drink, and comedy show, then I'm sure Noam would be happy to have you.
Are you married?
I am, yeah. Guilty.
Periel's married too, so.
Is that allowed?
Can you keep a secret?
Nick Griffin, your special. Do you have any, Nick? Do you have anything to plug besides your special?
No, just go see my special at Amazon Prime. Cheer up.
Nick, I hope you enjoyed this episode.
I did. I hope I contributed enough to warrant another invite someday.
I'm more concerned whether you had a good time than whether you contributed to us.
No, it was a good, completely entertaining. I had a blast, and I thank Periel for asking me.
Nick, you have an open invitation. I tell you that all the time.
Okay, thank you.
He talks to you like one of his lovers.
Comedy Cellar podcast at comedycellar.com for questions, comments, suggestions. Do you want more David Kipping?
Yes.
If you do, let us know. Do you want more Nick Griffin? If you do, let us know. Or any other comments and suggestions that you might have. And Periel, what's our Instagram account?
Our Instagram is at Live from the Table, but it occurred to me that for everybody who's listening to the audio, these are also on YouTube now. I feel like a lot of people might not know that, so they can
start
come.
saying that at the top of the show.
Yeah, you guys can come watch this on the Comedy Cellar's official YouTube channel.
Not well. If you want to listen to it twice, you can go back now and listen to it and watch it.
Okay, everybody. We'll see you next time.
String theory.
Thanks, everybody.
And
Thank
that is
you.
all. Bye-bye.
Thanks, David.
Bye, guys. No,
Professor.
and Dan, don't sign off.
Oh, okay. Bye.
Bye.
Bye, Nick. Bye, Professor.
Bye, guys.
Bye, David. Thank you.
Bye bye.
I